Hello and welcome to Parabolas in the fourth form, which is focused directrix form. This is a new form. You've never seen it before. I did give you some guided notes in class. If you didn't get those down, I'll make sure to tell you which slides you need to write down. You need a calculator, a pen, and a pencil, or a pencil. Okay, so this is a parabola, and we are going to talk about two key features that we haven't seen on a parabola before because we've never had it in this form. And one of the key features is this big black dot, and that big black dot is called the focus, okay? And it's always inside of the parabola. Okay, it's always inside the U shape. The directrix is a line outside of the parabola, and it's always outside of the parabola. Okay, and now those two key points help us with our parabola. So what we know is that if we take any point on a parabola and we draw a line to the focus, and we also draw a perpendicular line down to the directrix, those distances will be congruent. Okay, any point. I draw a line to the focus, I draw a line down to the directrix, and I will have the same measurement. Those measurements are equal distance because a parabola is a set of points that is equidistant from the fixed point called the focus and the fixed line called the directrix. That is so that a parabola will curve. It gives its curved shape. In order to maintain those distances, the parabola will curve to get the curved shape. So that's how we get the curved shape of a parabola. Real life, we have satellite dishes. Satellite dishes are parabola shaped, and they have this receiver inside the parabola because signals come in, they hit the parabola, the satellite dish, they reflect off into the receiver, and that receiver acts as a focus so that then the channel can be focused onto your TV and received onto your TV. So that is the real life idea of a parabola and where we get parabolas and the focus part of the parabola. All right, this is really important to have in your notes. The focus lies on the axis of symmetry and it's inside the parabola. You should know that the directrix is perpendicular to the axis of symmetry. You know, those two things will always be perpendicular. And the directrix line is always outside of the parabola. The vertex lies halfway in between the directrix and the focus. So these two segments are congruent, if you see that there. And then that idea of from the focus to each point on the parabola and then down to the directrix, we also have some equal distance things happening there. Okay, just another illustration in what those important terms are. All right, the focus directrix form. This form is where the vertex will always be 0, 0. Now we have been graphing x squared graphs. X squared graphs always either go up or down. How do we know if they go up or down? Well, usually once we graph it, we know. But today we know that if p is positive, the graph is going to open up, and if p is negative, the graph is going to go down. Now this is something you've never seen before, and this is a y equals graph. A y equals graph sits on its side. It either opens left or it opens right. So this would be right and this would be left. Now, how do we know if it's going to open left or right? Same idea as opening up or down. If p is positive, it will open right. If p is negative, it will open left. Now, what is p? P is a very important value. P is, just let me move this thing out of our way here. P is the number of positive or negative units. It's the distance from the vertex to the focus. And so that's a really important piece of information. We really need to know what P is. So if you haven't written this information down on your notes, please do so. So it's the distance from the vertex to the focus. We're going to need to know that in a minute, so keep that in mind. All right, let's go ahead and start graphing. Graph number 1. First of all, I'm going to rewrite this so it's x squared equals negative 4y. It just looks easier for me to write it that way. We're going to identify all these pieces of information as we graph it. Okay. The first thing is we have to be able to find p. And so to find p, what we're going to do is we're going to do the generic formula. The generic formula is x squared equals 4py. Notice how the x squared looks the same, the y looks the same. The only thing that's different is these two pieces. Well, what we can do is we can say negative 4 equals 4p. Divide by 4, and we will get p of a negative 1. Now, p is negative 1. And because it's negative 1, that means it's either going to go down or left. Now, an x squared graph is either up or down. So it has to be down because p is negative. So this graph is going to open down. Okay, the vertex is always 0, 0 here because we're working in 0, 0 form. So we're going to plot 0, 0. We're going to label it v so we know it's the vertex. The distance that the vertex is from the focus is your p-value. So this graph is going to go down, so the focus is going to be down because the focus always has to be inside the parabola. So that ordered pair is 0, negative 1. Okay, the directrix is outside on the other side of oops, excuse me, I drew that line wrong. The other side of the vertex 1 unit away, because remember, the vertex is halfway between the directrix and the focus, and that directrix would be y equals 1. Okay, and before we do the axis of symmetry, we're going to graph the rest of this parabola, and what we need is this value right here. That value right there is called the focal width. Okay, and that would really be 4, not negative 4. And so what we know about the focal width is that it is the width of the parabola through the focus. So we go to the focus and we have to make the width 4. What do we know about a parabola? It's symmetrical. So if the width is 4, my points are 2 units away, because half of 4 is 2, on each side of the focus. Okay, now there's my parabola. Those are the only 3 points I need. Now, if I draw my axis of symmetry cuts my parabola in half, right down the middle, and that would be x equals 0. Now remember, these two have to be perpendicular to each other, so one has to be an x and one has to be a y. The domain is x such that x equals all reals. And the range is y such that y is less than or equal to 0. Okay, and that is how we graph in focus directrix form. Let's do one more. This time I'm going to do a y squared, okay? Y squared. What do we know about y squareds? Yes, we know they either go left or they go right. They're new to us, but we do know that they either go left or right. So we've got to identify our p-value in order to determine if it goes left or right. So our p-value, this would equal 4p. Okay, just like in the general. So 4p equals 20. P would equal 5 because I divide both sides by 4. So my vertex is 0, 0. That's always the case. 0, 0, vertex. My P is 5. Okay, well, I need to know if it opens left or right. P is positive, and we know it either opens left or right, and so it would have to be right if P is positive. So we're going to go right. So then what we do is we go to the vertex, and we go right 5, and we draw a little F, so we know that's our focus. What's that point? That point is 5, 0. The directrix will be 5 units on the other side, but it's a line, remember, not a point. So that line would be x equals negative 5. All right, now, in order to graph the rest of the graph, I need my focal width. This 20 is the focal width. All right, so the focal width is 20. That means through the focus it has to be 20 units wide. That means I need to go 10 on each side of the focus to get 20 units all the way across. Then I draw my parabola through those 2 points, making it a nice U-shaped. Okay, there's my parabola. Then I draw the axis of symmetry to cut it in half. This should be y equals 0. Y equals 0 because it's a horizontal line. All right, and remember these should be perpendicular. One should be an x, one should be a y. Now this is for domain and range. We change this because it's a y squared, they reverse roles. So the range is y such that y equals all reals. Instead of the x, it's the y now because it's a y squared. And now the domain is x such that x equals, oh, here's the vertex, everything greater than the vertex. Everything that way of the vertex, so it would be greater than or equal to 0. That would be the domain. Okay? And that is graphing in focus directrix form. All right, we'll see you tomorrow.